Hello, depending on where you are joining us from, good afternoon, good evening, and good morning as well for those in the UK, and welcome to our fourth now digital talk series as part of our RIBA Hello China campaign. I'm Aslina Bulmer, Director of International at RIBA. Thank you for joining us for this talk with Professor Philip Yuan, founder of ArchiUnion and professor at the College of Architecture and Urban Planning at Tongji University. The RIBA Hello China program of talk really does showcase the best in contemporary, established and emerging voices in architecture in China, and we are generally thrilled to be streaming Professor Yuan direct from Shanghai for this talk, whilst all of us are based across the world, some at home and some perhaps others at office. Before I introduce our very eminent speaker, I just want to say how pleased we are with the many connections we have forged in China and surrounding regions since the opening of our office in Shanghai in December 2019. The opening of our international offices in Shanghai and Sharjah last year really has enhanced the global connection of our IBA community, enabling exchanges no matter where one may be. In this increasingly difficult time, a vibrant global connection has been integral in keeping us all together as a global community, despite all the challenges we are facing. The RIBA launched Hello China campaign earlier this summer, where we are delivering a series of events and thought leadership activities throughout China. Keep a tab on our Chinese website for more information, which is www.riba.org.cn. And also for those who have got WeChat, and I know in China that's essential, RIBA has an account and it's simply called RIBA China. For those outside China, architecture.com has all the relevant information too. Now, moving on to our speaker today. Professor Yuan needs little, if any, introduction for many, I'm sure. His resume is exceptionally impressive. Yuan is a visiting professor at MIT and at Thomas Jefferson UVA, a founder of Fab Union Technology and director of the Digital Design Research Center in Shanghai. Yuan's practice combines exceptional architecture with world-beating technology. RIBA Journal did an article on Yuan recently, and the title of the article is Meet the Techno Wizard of Shanghai. And as he focused largely on implementing computational design and robotic fabrication into local traditions and culture, that description seems apt indeed. And it is of no surprise he has received many awards for his projects. Yuan's work has been exhibited worldwide and entered the collections of several renowned museums, such as the Museum of Modern Art, MoMA in New York, and the M+ Museum in Hong Kong. I'm sure you are all looking forward to this talk as much as I am. So I'm going to be handing over to Professor Yuan imminently to start, but before I do so, just a couple of housekeeping points. Since we are using Teams webinar for this event, we cannot see or hear the audience. So should you have any queries, do use the Q&A function and we will get back to you and support you. There will also be an opportunity for questions at the end from audience. So please do ask questions and again, use the Q&A function. Submit your questions at any point and we will be asking those at the end of the day. It would also be great if you could just say hello and tell us where you're dialing in from so we know where you are. Well, that's all from me for now. I'm very happy to hand over to Professor Yuan for his talk. Philip, over to you.
Okay, thanks a lot to the kind introduction from Zelina. It's a great honor to be here. This is Philip Yuan. I'm based in Shanghai, so I want to say good afternoon to Chinese audience and good morning to the audience from UK. And hopefully it will be a great opportunity for me to introduce what we're doing here, including our research, our practice, and what we're thinking as a Chinese architect, and how we implement different kind of new technology and including different kind of practice here in the past few years. So the topic today I want to make the presentation is fabricating hyper objects. Okay, let's go to The key words I want to present in this lecture: de-territorialization, rematerialization, natural geometry, high performance, non-local locality, and digital futures. It seems like quite different keywords, but actually which make a connection of what we're doing in the past few years. So let's start. I think right now it's a very special moment. People encountering with more challenge and difficulties in the past pandemic era. As an architect, being involving in such initiative that is freely open to the public and accessible for international audience, it is quite meaningful. Global disease, riots, and all uncertainties that taking place in our surroundings and everyday life inform us that human may not be only dominant group regarding to the inhabitation and built environment. De-territorialization. As Deleuze and Guattari mentioned in Anti-Oedipus in 1972, there is no such thing as either man and nature now. There is only the process that produces the one within the other and couples the machines together. So the discipline we're engaged right now is architecture discipline, architecture design. But actually what we're doing in the past 10 years, we try to create or try to test what is new boundary of this discipline. So the de-territorialization actually is from what we're doing in the past 10 years. I founded Archi-Union 10 years ago in Shanghai. We aim to integrate the digital fabrication research with the local craftsmanship and materials in bringing the strong regional character to very contemporary architecture designs. So here is all you can see, which you can see the process of the ivy, the green, which is growing in our garden. But at the same time, we're working in front of this very small piece of green land, which embracing this kind of the open environment in the downtown Shanghai. So which is the very clean space, represent what we're thinking, we try to make in such an environment. So in Eastern world, because culture actually is quite different to the West, the culture-oriented strategy towards the tectonics, materiality, and the built environment has been demonstrated in architecture expression over years. Throughout years of practice, Archi-Union architects has been employing digital tools and advanced technologies such as algorithm library and robotic fabrication tools, and resulted in a new authorship which transferred from the theory to praxis. So you can see this is the axiometrical drawing of our office, including the exhibition space. We actually organize a lot of special event, including the office, and most especially we have a robot yard inside of our office. That means although we are designers, but at the same time, we employ the robotics as a partner to stay with us, which engage a lot to the real practice in the last few years. So this is a robot yard, which located inside our office. We set up everything in 2015. And before that, we spent almost 3 years settle down everything and make a lot of research. And on this platform, we already developed 12 different new crafts, including robotic timber structure, 3D printing, welding, etc. And in the past 5 years, we try to engage or implement all these kind of crafts into our project. So in the next part, we want to introduce project by project how we implement this kind of new technology in the practice. And 2 years ago, I invited a very important philosopher who is from UK, Andy Clark, coming to Shanghai to make lecture for my student. And I think what he mentioned, the very special natural-born cyber influence a lot, also which is a parallel to analyze what we're doing, why we employ robotics as partner of us. I think perhaps human nature to adapt new tools become new fashion. Actually, it's become. I think the robotics become our new prosthesis, which can enlarge our arms and taking more heavy materials. And due to this kind of a new plasticity of human brain, the new technologies could be constantly absorbed within our body screens and become extensions of our body. So the skill of our arms and also the precision of our eyes could be extensioned through different kind of machinery platforms. So that is actually the infrastructure what we set up inside our office. So the next keywords we go to the rematerialization. Material has been central topic and the central drive of architecture for a long time. In the digital age, informational control machines becomes parts of the production process, not only allowing us to introduce or invent new materials in architecture, but also open up new materiality and speciality by embedding the characteristic of digital information into those materials. So the first project goes to the 3D printed Taihu rockery in Suzhou, Master of Nest Garden, which is the most representative garden in China. Last year, we participate. Both Zhang Li from Beijing and me got invitation. We participate in this exhibition. Dian Chunyi is a garden inside the Master of Nest Garden, which is although not the largest, but one of the most representative in Suzhou Garden. Metropolitan Museum in New York collected this garden and named Mingxuan, reproducing it in New York City. Recently, Luca Motiliani, the former curator of Milano Triennale, curated the very special contemporary exhibition inside the garden, which I was involved in. Through the robotic plastic printing technology, we create artificial stone and embed it into the context of Dian Chunyi. And then in the view, you can see very special 3 different kinds of rockery, which represent the topic called what is the hyperobject here. The middle one is natural format Taihu rockery from Ming Dynasty, which is like an ancient rockery, represent the history of this garden. But the upper one actually is artificial craft stone made in the period of Republic of China, which is almost like 80 years ago. The lower one is our exhibition project, which was used recycled plastic, implemented robotics to print it. Be involving into the continuous making progress of the garden. I think it's kind of a new daily life into this tradition garden. We would like to propose a contemporary view on the relationship between what is artificial and what is natural. Here is a visitor who is lying on this stone. So the stone is not just for looking, it's not just like a natural element. Here it's become like a bench or like a different kind of furniture, which engage into the garden. So the object itself is not just a looking object, which is an object represent the environmental friendly material and goes to a new function of this tradition garden. And the second project I'm going to present is also by the modified plastic. So modified plastic could be environmental friendly, recycled material, and we make a lot of research on that. So this project, the most special I want to highlight is everything is start from the post-pandemic. So it's a little bit serious because after Chinese New Year is really serious. People cannot go back to the factory, cannot go back to the construction site. And we employ 8 robotics to working with the designers. Designers actually are working at home. We control just through one controller inside the factory to print everything and to fabricate everything, which is not inside the traditional working flow, which is quite the online or digital making process for the project. So here we go. This is 2 weeks ago. I visited the site, and which is almost finished, and it's very interesting. And the project name is the Happy Valley Theme Park, which is entrance with very colorful, attractive material. So overall size, the scale for the printed plastic is 42 meters length and 24 meters width. So in this project, we implement the geometric topology in the formation process, integrate with the multicolored mosaic pattern, and redefine the freeform geometries in spatial design. So here is another perspective, although not all finished yet, but you can see the very important 2,000 prefabricated panels which cover the surface. Most of them are a double curve, which is no similar two-size panel, which is every panel is different in this project. So here, how to fabricate them? So every single panel was precisely positioned according to the laser tracking system, so which is the very developed position with to show the accuracy and the efficiency how we construct this pavilion, this building in such a short time. And the application of 3D printing technology and the position with this kind of laser tracking tools make it possible for such a dramatic form could be finished in such a short time, especially after the pandemic, this very difficult time, not only for designers but also for the workers actually. But we make it. So this is the project I want to introduce as the second one. So I think from a geometry perspective, it's a very interesting one. But most importantly, the material we implement and the new form goes to the very speciality and the creativity and this kind of a process for how we can achieve in such a short time. And the third keywords I want to analyze here is natural geometry. As actual representation of architectural material is also the key to mediate architectural geometry and natural environment. By exploring new materiality with digital tools, the intrinsic logic of the generative process of architectural design could reveal the invisible forces in nature and construct a dynamic correspondence between the forces and the architectural geometry. The tea house, right now what I'm stay here and to make the presentation, so it's located in the backyard of our union office, as the site was extremely constricted with walls on three sides, and which only one side facing towards the open space with a big tree situated in front of this building. Actually, you can see the ground floor actually facing with the trunk, and second floor actually the branches and leaves are shading the glazed windows. So this is actually the second floor. You can see the inside interior exterior space are embracing with each other. It's very just by the transparent window, and which is a library here. And actually in the afternoon, although the glass facing west, but actually the shading of the leaves give very interesting shadow to the space. So yeah, the special entrance also including the twisting in-between space between the ground floor and second floor, actually, which is stairs leading, only going upstairs, you're facing with the branches on the top of the head. You can see the branches at the same time would lead you to the light, and you can like going through outside space to interior space. So the drama system here is kind of roof surface we implement, including to integrate the structure system with kind of roof surface together. So a very special experience because the light is very strong to the west, but actually inside is very dark. So this kind of experience from this space to that space is all invented or created by this kind of a new geometry system. So the geometry here is making a very special object. The object itself has inside and outside, have this kind of dark and light side, which give us a very strong experience through it. Another project here I want to introduce is 5 Unit Space, which is located on the west band of Shanghai, and we designed and constructed in 2015. So this is like another twins for the formal project. Actually, the geometry system is really special. So you can see this is the art and exhibition space located on the art area of Shanghai, the West Bund. And the neighbor is the Shine Art Gallery, which is the most representative gallery in China. And we try to create a space to make different kind of exhibition. So the height of the building is 10 meters. So we design the right side with 2 5-meter space and left side 3-meter space. So this kind of section produce different kind of diversity. You can imagine the 2 stories, 3 stories, how they can engage with each other and connect with each other. So we try to design a 3-meter wide stair or circulation space to not only invite people go inside or to organize the circulation, but also we want to integrate the structure system into this circulation. So that's the challenge for the whole design. From the exterior, you can see the light washing the concrete, the whole material of the project's concrete, washing the concrete. The right side is from the top and the left side is from the window. Although the stairs is the scale of the building is really small, but actually, if you're looking from this space, this perspective, the gravity of the concrete and can give us, and also the light of the shadows can give us a very strong spatial experience through this kind of geometry. So the geometry here is not just a roof surface as a geometry, but it produces a kind of materiality and produce a kind of light inside this space. You can see the materiality. The material here is a kind of raw material, concrete. The roughness here produces a kind of quality because we can see the roof surface line is there. Although it's very raw, it's not very accurate. But when we produce different kind of performance here, you can see the very strong contrast through this kind of space. So here is analysis of circulation. You can see the 2-story space, 3-story space. We actually created this kind of diversity, is how to invite people coming from this space to that space. Actually, we firstly design circulation and try to implement the special structure performance-based optimization, which named BSO. We collaborate with Mike Shea, who is a structure engineer from Australia. And he gave us a very strong structure performance-based design methodology, which just to delete the unuseful agency of the structure. And lastly, we left is the structure part. So this is a process of different steps, how to delete the unuseful material. And lastly, the structure itself is coming out. So from this kind of formation, you can see this kind of digital formation. The object is produced not just by the looking, but also the structural performance as well. And we use roof surface to polish the surface and make it more like continue. And the construction process is really difficult because it's not a linear process to produce the mold for the concrete. So we use different kind of models to teach the workers how to define the boundary of the geometry and how to construct the geometry. So, and lastly, coming out this special building, when we take the first look of this kind of space, I just got stunned because it's really special. It's out of the imagination. So sometimes this kind of digital tools, the computational geometry gives us a lot possibility to create a new experience for the buildings. At the same time, the structure high performance gave us opened a new, very important horizon for us. So the high performance is the keywords. we actually implement in our design process. The relationship between the architecture environment, which has been brought on the table, the recursive morphogenesis process could be established to find optimized geometrical result from the enormous heterogenetic possibilities. In this way, digital tools open a new way of addressing high performance in architecture. The integration of digital design and fabrication through data transmission establish the production feedback loop consists of formation, simulation, optimization, and construction. So I want to put 3 bridges, which is a research project I'm leading in the studio with my student in the past few years, 3 years. And one by one, I've just introduced the high performance research methodology. So this is in 2017, we designed and fabricated this modified plastic bridge. And the most especially the weight of the bridge is like 1,000 kilos, it's like 1 tons. And only 5 people can stand in it. So calculate the maximum we can stand in 5 people on it. So you can see the process. We make analysis by the forces of the support, how to support this bridge, and we printed the forces by the robotics. And 2 robot arm can print 2 different kind of components. That's very special, and make it super efficient. So everything will finish more than 10 days. And the second year, this is another bridge. You can see 7 people can standing on it, including Chinese architect Wang Shu and also 2 MIT chairs, Mi Jingyong and another Tarani. They coming to visit our school and standing on it. So you can see totally 7 people standing on it, and the weight of it like 700 kilos. And you can see it's lighter and more efficient, and more people can stand on it. The ways for fabrication is how to translate this kind of structural performance forces to a kind of geometry and integrate this geometry to a high performance footbridge. So this is the fabrication process. You can see the details for this kind of welding, robotic welding details, give a special quality of the crafts by the robotics. And third year you can calculate. We have 20 people standing on it, and the weight of it goes to 450 kilos. It's higher and higher efficient, lighter, but more people can standing on it. So this is the process, how introduce how we fabricate this bridge. We spent 20 days for this one. The structure spans 11.1 meters. Rises 3.9 meters. The connecting the ground floor and the basement of the school with millimeter construction precision. The main structure thickness height only 20 meters with the help of Machine technology, topological optimization software based on the BSO, which is optimization software, give us a precise structure, which like the bones of a human being, to support the whole bridge. But the special form could be only printed by the robotics because it's a free form. And including the stairs, we make analysis of forces, how the forces flowing on it, and translate this kind of geometry and to filament weaving by the robotics. So this is the whole process, including the 3D welding and the filament weaving. So this is a simulation for the weaving process. We employ not only the carbon fiber, but also the glass plate for both compression and tension. This is a machine we research and invent. So this is the process, how we collaborate with the machine to weaving this kind of filament. This is glass fiber, and dark one is carbon fiber. Carbon fiber for tension and last slide for discussion. This is a bone, main structure of the bridge. This is a scale of the bridge, and also the handrails as well. So the fabricating process produces a kind of a new quality, new details for the footwork. We name it as a kind of new aesthetics by the robotics. This is the construction process. Everything is preset, very efficiently, just one mount. Put it on track. Okay, this is the final bridge, the final view of the bridge. And you can see the new beauty of this kind of material and very high performance, which is semi-transparent, and the sunlight, the shading produce a new kind of beauty. So here is the three bridges. As a conclusion, you can see the higher and higher performance and gives the new efficiency and the new beauty, which is produced by the computational design methodology and the robotic fabrication tools. The ultimate objective of research is to experiment, and through the experimentation to establish a kind of credibility. So as an analog of the scientific laboratory, the design laboratory would be lead rethinking on the tradition authority of architecture design. So which is replace the kind of the background of my research and practice. We try to employ this kind of new tools and collaborate with them, and then make a new kind of creation and produce a kind of new authorship from the office. The next topic will be non-local locality. Locality has been treated as a critical issue of architecture since the modernism movement, and has been also injected with new questions after globalization in 1990s. In the contemporary world, the boundary between the global and local need to be reconceptualized and go beyond and single dialectic understanding of the term regional. And the rapid iterations and the massive distributions of current technology, architecture evolved in technical world so deeply that locality can be no longer separate from the social production process. The local environment will not purely refer to the nature and the cultural animal, but to the cultural natural world with interventions of technology. So actually, although the practice of the local practice, but we employ the non-local, the new technology, and try to engage the kind of new technology into the locality. So that's the things I want to highlight. So non-local lies in the emphasis on the form finding over form making, on the bottom up over top down process, and on formation rather than form. Indeed, the term form itself should be relegated to a subposition and the term formation. Meanwhile, formation must be recognized as being linked to the terms information and performance. When architecture is informed by performative considerations, it becomes less a consideration of form in and of itself and more a discourse of material formations. So we have different kind of implementation, different kind of research. And first goes to the robotic brick mansion. So I want to introduce my project. So this is the Chicago Biennale in 2017. We present 3 projects there, including Fabulous Space, Qishe, and In Bamboo. And the right to one was collected by the New York MoMA, including the models, videos, everything. So Qishe is a project which was known as Pond Society in some media platforms. is the storied homogeneous combining advanced robotic brick mansions and historical traces. In this project, form is not purely by looking, but also implicating the innovation of traditions and nostalgia. Professor Philip F Yuan, who is the Dean of ETH, recognized this project as a piece of matter and mind. So here we go. This is the Chisa project located on the west band of Shanghai, the art era. And we select a material which is the recycled, used tradition bricks, because people tear down other buildings. We collect them and want to reuse this kind of bricks. So which is really difficult by the machine. So we try to create a special geometry on the entrance. So we have a shading, which is like a special unlinear space at the entrance of the space. But the most especially, we put sensors on robotics to scan this kind of recycled bricks and recognize and provide the real-time feedback of the unique characteristic of each non-standard recycled brick, which help us to precisely place each brick to achieve the global geometry form. So this is final. You can see both this kind of roughness, and also you can see the position of the bricks on this special design facade. Actually, the whole process of design is we parametrically design each brick. So every brick have a special location, actually, which optimize by different kind of performance-based tools, including displacement, stress, wind load, and different kind of structure, which is embedded into the geometry of the bricks, including the density of the bricks and the location of the bricks. So this is a process of the whole project. So although it's a super small one, but quite influential and quite meaningful to us, because we actually embrace this kind of new high advanced robotic brick mansion technology, and the sensors and different kind of sensoring process of the project. So it's super difficult, but super meaningful to us. As to the inside of the space, the light was invited to washing down to the main wall of this exhibition space. You can see which is quite pure and clean with double layers of facade, and also the stairs leading people going to the second floor. So this is the project I want to introduce. And okay, next project and also the crafts we want to introduce is carpentry. Carpentry is a really traditional Chinese or Eastern world technology, actually. In the ancient time, and we implement this kind of joints, not only in the building, but also in the furnitures. But right now it goes to really difficult to implement them. Maybe just in a special project, but very difficult to use, example, wood joints in the real project. So this is a power project I teach my students in Tongji, and the project includes 12 layers, and which optimize them through 4,000 components to 800 components. But the most speciality for the project actually is every layers, the components have different joints. If human being fabricator will be super slow and spend a really long time, but actually in the collaboration with robotics, we only spend 2 weeks to fabricate everything. So including through this image, no nails, it's all joints, and the position of the joints actually is created by the robotics. And you can see this kind of joints, and every layer actually the joints is different. And my students actually know they are not carpenters, but they can employ the robotics, collaborate with them, and actually they're working together to be a carpenter, new carpenter, which is a machine and human collaborative carpenter. Another project I want to introduce here also is timber craft. Is the project we participated in Shenzhen Biennale last year. Through the video, you can take a look at them. The name of it is nomadic wood, and which is a kind of formation by the computational tools. And we're twisting this kind of timber actually is incredible because people cannot really doing such kind of curvature on wood material. So this is a process. Take a look. I think the process is on the special crafts and how we can make a full use, very efficient use of laminate wood. Because laminate wood is quite industrialized and environment friendly because people can planting different kind of trees and every 12 years collecting part of them and through this kind of very thin and laminate to very strong pieces. And actually we transfer the curvature twice. The first time is a kind of one curvature timber, and through this different kind of factors on the robotics, including this flat saw, band saw, and this curvature saw, and also we have a milling machine, it's double arm, double robot can collaborate with each other and very efficiently fabricate this kind of techniques. And precisely define this kind of curvature through the robotics. So this is really just like prefabricated components, and this is like furniture, how we make furniture in China to put them together, different components. So this is the project by the robotic timber project. And the real project goes to also in Nanjing, the Happy Valley. We just finished a building by timber structure. And also we put some PPFE on the top of it. So you can see this building clearly. So 2 elevators is coming out. And people, we set up a geometry and embracing the people from 2 different kind of directions. You can see the material, the semi-transparent light coming down, and with warm timbers to welcome people coming into the site, which is almost finished. I think we'll be finished in 2 weeks. Also, another project I want to introduce is the Light of Internet Explorer Center in Wuzhen. I think 2 weeks ago, Professor Xiangning Li also introduced this project to the audience. So the project designed by Yiming and was completed in 2019. So the Wuzhen Internet Conference is one of the most representative high-tech conference in China. They try to express some kind of real surrealism style involved by the arrow and to the region of Yangtze River. We would say the new building space is defined a stage for the new activities in the post-humanism. And Jiangnan, which is a very important special location on the south side of Yangtze River, and remains a very long history and a very tradition. You can see the tower in the front, and Professor Wang Shu designed the phase 1 for this internet building, and my office was invited to design the phase 2. So this is phase 2. So the complex building, including the main exhibition space, 25,000 square meters, and also an information center, which is like 5,000 square meters. And we designed also four different pavilions, which is all fabricated by the robotics on the side park. So this is the whole project. The most special I want to highlight here is the whole design and construction time schedule is 6 months. So you cannot imagine in China how fast it is, but how to efficiently and high quality produce the design is a challenge to us. So this is the whole process of the structure design and the structure efficiency, suspended roofs with suspension cables, which is like 100 by 250 meters span buildings, and including the suspension cables and steel strips require a low amount of steel, but the construction control of the detailed design is flexible system are relatively complicated. In between the main string beams, we created the proposed use the cantilever beam to make the connection. The structured prototype is derived from the suspension structure, different from the conventional suspension structure, through putting tension on the steel and to put maximum mechanical property. It saves a lot of time from the form finding process of the cable. We replaced the steel cannel with I-beam to realize the complicated form. 230 catenary beams are unified into the circular segments with the same radius and greatly reduce the fabrication difficulties and reduce the chances of the machine errors. So this is like the final facade, which is the facade is by the prefabricated panels. So we present a certain kind of wrinkles on the little river inside Wuzhen. So this is a kind of a special facade. And actually, another thing I want to highlight is the roof. Actually, the structure system try to employ the very heavy tiles to put on it to make the cantilever, this kind of catenary beams more safe. Actually, they need the weight by the tiles. So we use 700,000 tiles, which is not only represent the traditional material, but also gave the weight to the structure system. So the roofs, which is 20,000 square meters, consists this kind of 700,000 tiles. Therefore, it is merely impossible to construct everything on this site. You can see every 18 tiles combined together, and we put them as a component. So it's also prefab. We make everything on the floor and use a crane to hang them, put them on top of the roof. So this is like the reflection of the facade on the pond. So this is represent a kind of abstract process to understanding of the environment. Because it's super hot area of China, especially in the summer, so we try to create some kind of wind is flowing through the water pond and give a very good environment, shading environment for the side pedestrian ways, which is what we name as a special object to embracing with the environmental performance-based formation. So this is construction process, including the ridge spring beam and the interframe catenary beam. Composite structure has the ability to form a column-free 90 meters by 20 meters net space inside. At the same time, there is an opening at the top, introduce a skylight to improve the spatial quality. So this is a final drawn perspective. We see including the main building and the 4 pavilions, and also information building on the site, and shown by the same curvature of the roof, and with kind of red pavilion, and also this kind of weaving pavilion, we name it, and also a timber pavilion, and plastic printing pavilion as well. So interior space, you can see the rhythm created by this kind of curvature, which is every curvature is different actually. The curvature of this kind of curvature beam was wild by the double robotics. That's why this 230 curvature beams was constructed in such a short time. So everything was prefabricated in only 1.5 months because it's robotic fabricated. And also you can see the precision of this kind of beam, which put in the materials and give us such a good quality in such a short time. Another perspective. The light is washing down from the main roof on the middle. So actually no light was turning on you can have very good lighting experience inside the exhibition hall. At the same time, part of it will be open to control the wind flowing inside this main hall, exhibition hall. And beside it, we have a Starbucks Cafe, which is totally by plastic printing. You can see this kind of material, and when light turning on, it's very interestingly creates some kind of art space, another perspective in the daytime. And the red pavilion, actually today we have no time to introduce details, but actually we employ the robotic plastic printing to make a mold and create a 45 meter span by only 3 layers of bricks. So the plastic printing make a mold, and the real structure is bricks. So the 15 centimeters depth of the material create a 45 meter span. That's a super thin but high efficient. Actually, this is a computational design, RhinoVault, which is a platform invented by Philip Rock, who is a professor in TH. And our 3D printing technology gave a very high efficient, high efficiency fabrication tools to make it possible to create in such a short time. You can see the facade and also the 3D printing mold, which is the ceiling. We don't deliver them away, just put them as a kind of tectonic, architectonic process material on the roof. And the last but not least project, I think I still have several minutes. I want to introduce a project in the countryside of Chengdu, the In Bamboo project. So I also bring this project to Venice Biennale, and this is actually, we designed 6 buildings, but we totally changed the life of this small village in the last 3 years. So today, I especially introduce one of them, the buildings. The name of it is In Bamboo. So the project located in Daoming, which is a very traditional place, Pili site, and the representative for the local environment is Lingpan. So every small village is surrounded by bamboo and by bamboo forest, and also the bamboo industry is very developed. So we try to collaborate with local workers and collaborate with local materials, including timber, including tiles, and to try to teach them by the robotic timber methodology, and to create a certain kind of geometry. The geometry here on the roof you can see is a totally double curvature roof, and also we have different kind of BNB, and this is a special local community center, and another one is an industry exhibition center as well. And we want to go to mainly introduce the In Bamboo project. We make this exhibited in Venice. So you can see the tectonics, astronomical drawings of this one, including tiles on top, and we have some special beams on the roof, and also we have a structure, the column and the main beam system, the structure system, the whole building. So left the bottom is the sketches. Actually, this exhibition will be happening next few days in Miami design. I donate the sketch to help the Beirut bombing project. That's the special event organized by Amal, who is the dean of Columbia University. And the right one is a British model, which is connected by the M+ Museum in Hong Kong. But this is the main representation of the roof structure system. You can see actually the whole geometry is defined double curvaturely, and every beam, every column have different ones and different details. I think the robotics can have a very precise fabrication and can give us a very great position of different angles to cutting through the timber and the steel panel and the timber again. So it's super efficient and super precision. So this is a process we name as the digital twins, which the right one is showing the model, the left one is the real process. Actually, we control all this kind of curvature beams by this kind of robotic timber process. So this is a final building. We're looking through the bamboo and allotment, including different vegetables, still planting in front of this small house, a small building. And the building have the pitched roof, have the very familiar traditional materials, but actually the geometry is a kind of high geometry system. I think here is embracing with environment and also embracing with local industry, local people. The interior is actually no decoration. Everything is just represent the structure itself, including the beams, including the columns, right? So no decorative materials. It's all the pure material of the structure. You can see the still in the farming land, people working surrounding this building. So it's quite kind of a natural environment in the rural area of China. So this is a construction process. We make a guard for the entrance, and we're modeling the geometry in a very short time and try to invite the local bamboo crafter help us to fabricate. You can see the main master in the village, who is more than 60 years old. I talked to him, and he is super smart and tell us, it's really difficult for me to work in such a difficult project in the future, but this is a very special opportunity. I will try to help you to do that. So what he mentioned is like the new generation actually don't interest in this kind of tradition crafts, bamboo crafts. So he's looking forward to attract more young people to learning from him and to keep this tradition going on. And in the last few days for the construction, when I visit the site, you can see all the workers are women. So I asked them, where is your husband, where is your son? And they mentioned all of them go to the main big city to find the higher income job. So only the females left in the countryside. That's a phenomenon right now. What's his scenarios for the rural area construction site. So I think what we're doing in this project meaningfully is not just construct a building. We help them to set up a robotic timber factory, actually teach them how to implement robotics for the timber industry. And actually we developed some new for the weaving, filament weaving for the bamboos. I think in the future, the really important thing is to design this kind of high quality buildings, attract people to be proud of their hometown. And meanwhile, the most importantly, we should help them to set up certain kind of identity, which they have the local industry. The young generation, they would like to working not far away from their home, but to set up the new relationship between human being and the locality. I think this kind of locality is a certain kind of new dream to find a new harmony between the human and nature. Maybe I think the subject is not just a human itself. The subject is the collaboration between the human and the environment, between the new social process and how to attract the people coming back to the empty villages, and how to set up new opportunities for the local industry, local people. That is something I want to mention. Object is not just a building. The object is trying to find the new initial abstract models to really improve the edition of the social process. So that is what I try to present today. So thanks a lot to RIBA. It's a great honor for me as a Chinese architect to introduce what we're doing and what we're thinking and what we're trying to to set a new boundary of the discipline to make a new future. Thank you very much.
Thank you, Philip. That was truly a fascinating talk. I think you've taught us many things and the work of robotics and technology, how it works seamlessly with some of your project is very impressive indeed. So thank you for sharing that with us. There's a few questions that come in. The first one is coming from Sheffield, from Emma England. Says thank you to Professor Yuan for sharing his incredible work. It's fascinating to see the new forms created by the robotic fabrication. Does Professor Yuan think that robots or cyborgs would ever be able to tackle design problems instead of architects?
Okay. I think what I mentioned here, including the computational design, robotic fabrication, most importantly, I introduced at the very beginning, actually is a collaboration between human and machine. I think this is a new boundary actually, and a new discipline boundary we try to explore. But I want to quoting what is Andy Clerk mentioned at the very beginning. I think we are all cyborgs. That means the human, including we have the mobile phone at hand. We know how far away from the train station to our home, because the mobile can tell us how far is it, and what kind of bus or taxi you can, how long you can take to go there. So everyone, your ability was expanding by the new tools. So actually, the robotics is the same to architects. I think in the past, architects working with computer, working with different kind of fabricator of different kind of company. But in future, as new possibility, your partner may be probably not a human being. Your partner could be a robotics, could be a robot arm. You can produce a tiny or small business, actually, which is just fabricate a chair or maybe doing some kind of material window or some kind of crafts. But I think that's a potential future, because this kind of cyber future is what is really happening. So the cyber future, not only the robotic, but also different kind of intelligent algorithm, which can help us to generate different kind of form, can find a different kind of possibilities to make a full use of different kind of big data. So that will open a new window to give us a new horizon. I think if we embrace in this kind of new culture, human being is not means just by the real human being. The body is not by the human body. The object itself is kind of new centric for the future, including the robotics is a new object, including the algorithm is a new object. They have their own consciousness. So the new future is how the human being can make full control of the future, is how to make a good collaboration with the cyber, which collaborating with us.
That's a very good answer. I've never thought of that, about the collaboration we are already doing, which is every day, of course. And I think this probably relates to the issue of the next question, which is about climate change, which of course we know is one of the biggest challenge facing mankind. And how do you think in collaboration with technology, we can support the work required in design to address the issue of building sustainably and, trying to help with the current issues we're all facing with construction and its emission, particularly around climate change issues that we're seeing all over the world, particularly in developing countries as well?
Yeah, I think it's a very good question. The climate change is actually the real problem we need to face, we need to encounter from all of the world. And most importantly, I think I highlight the special topic, what is hyper object, is I think including the environment is outside of our body, which have a subjectivity. I think in the past, we are all the human-centric. We are the center of the world. Human beings are the center of the world. But we make it actually facing with a disaster because the environment have their own special rules. If we don't follow these rules, the disaster will come in. So I think that what we imagine in the future is a harmony, how the human being. It's kind of new humanism. This humanism, the post-humanism someone mentioned, is the human being should set up a new collaboration or new authorship or new relationship with the environment. So both the human being and the environment have their subjectivity. We should set up different kind of rules to follow what's the reasonable relation between human and the environment. So what in our methodology, I think performance-based design, I mentioned high performance building is a kind of ways we should think about, because more efficiently use material and high efficiently produce the buildings, and also how to low carbonly develop our built environment is what we should do in the future. In this context, most importantly is advanced technology should help us to make the building process more meaningful, not just for the good looking as aesthetics of the beauty of buildings, but also the aesthetics of performance, aesthetics of the new ethics of the environment. So the environment problems should be translated into the building process, which including how to make efficient design and how to employ different kind of performance-based tools to help us generate different kind of form. So the new form is we name as a new kind of object, which looks differently to tradition. And then when you need robotics to make to fabricate this kind of differentiality and to fabricate this kind of differential facade, because which you need a new high performance building always have a non-linear surface or non-linear facade system. So this kind of customization will follow by the performance-based design. So that's the initial logic I want to explain right now. The hyper object is not just for hypergeometry, which is more relationship with the performance-based thinking and ethics of the environment. So that is something we need to set up again. And followed by this, I think the industry and the social process should be redefined. That's why the future of the new social industry should be set up by the collaboration from the human being and different kind of intelligent tools, including the computer, internet, and IoT, and also robotics, this kind of new tools. They will help us to set up more precision, have a kind of a feedback to the environment problem. So that is something I want to introduce.
That's fantastic. And I think yeah, it is very much something I know that you're working on, and it's great to hear your views on this. Another question is simply on scaling up. You know, we've seen some great examples of using robotics in a customized design construction. Do you think we will get to a position where we would be using robotics in a much more scale-up construction? Everyday buildings, that is what this question is all about. Do you think that's within reach now?
Yes, absolutely, yes. Because that's the very special part for my practice, because we set up the practical part by one is Arch Union, which is a design office, and Fab Union, which is a robotic factory, which is totally experimental platform for the construction industry. I think not only us, but also a lot of very big firms in China, including the China Construction Group and the Shanghai Construction Group, they all start to update the version of the construction industry. I think there is a big trend which is like booming in China in the past year, and right now it's like every month we participate different kind of conference and different kind of talk, because the architecture industry is right now in China, especially, I know the government and also the business part encourage people to update the version to more efficient and more intelligent. So that is what is already happening. including, for example, we construct the housing project, apartments, high-rise apartments. Right now in Shanghai, the regulation is 40% of this kind of building should be prefabricated by PC, which is like very big prefabrication industry. That is set up in law. That means they not allowed on-site work anymore in the future. And right now 40%, maybe several years 70% is coming. It's all should be prefabricated. That means in the factory they should implement robotics and different kind of machines to more precisely construct this kind of, efficiently construct this kind of building components, and then to just fabricate them, put them together on site. So that is some updated version, this kind of customization in the building or prefabrication in the building industry will be the future. I believe that is already happening. The future is coming.
Well, that's really quite timely because it ties into the next question and our final question about the prefabrication and speed. The speed of construction using technology in a number of the projects you talk about is very impressive. You know, in the current global crisis we're facing, it feels like robotics could be the answer or part of the answer for quicker build for essential buildings like hospitals. In a cost-effective manner. Do you think this is achievable for us now?
I think build this more efficiently not means we lose the quality. So yeah. I presented the Internet Center project, which is constructed in 6 months, 30,000 square meters. That is an extremely big project. But why we can fabricate and construct it in such a short time is because of the working flow, the creating process from the designer, and we create the model in the office. And why it is so fast is from the model to the construction is we have robotics as an agency to translate our thinking in a very efficient way. So that is something really important. We still have the high quality custom and very special geometry system, but actually we not lose any quality. That because of we employ the robotics, the new tools to collaborating with us. And the designers can control this kind of fabrication process without a lot of consultants that makes things very complicated. I think that is some revolution will redefine how we construct a building in the future. That is already on the way, but actually we need to rethink on the education and how we teach a student, how we the practitioner, that professional architect, they can update the version of their creativity. So in the past, we defining a kind of humanism of the core quality of creation, but I want to announce the core of creativity is a kind of new collaboration between the human creativity and the machine creativity. So you need to understand how the machine as a subject, they have their working flow, how they can work more efficiently. And your creativity should embracing this kind of collaborating with kind of new tools. That is something really special I want to highlight in my practice.
That sounds fun. And it's a good note to end today's talk about how quality is very much integral in parts of what you're doing, using robotics, and it's not sacrificing that in any way at all. It's more about enhancing and collaboration and looking towards the future. I know that's all the time we have for today. I just want to thank you, Philip, for an exceptional talk and for introducing us, many of us, how technology can really play a pivotal role in design now and in the future. We are extremely grateful for you for your time today. I know it's Saturday and we're grateful for you for making time on a weekend for us. To our audience, Cameron Hales didn't ask a question, but he posed a statement: phenomenal presentation and body of work showing a humanistic application of technology. I want to say that because I think that is very, very true. Cameron, in terms of your question, will the recording be available? Yes, and I see my colleague has also answered that. Absolutely, we will be circulating this on architecture.com. There's also recording on YouTube, Bilibili if you're in China, and wherever we can, and WeChat as well. And to our audience, thank you for your watching today. We are planning our next RIBA Hello China digital talk. We are holding a virtual Pachakucha. Philip, you're welcome to join us next Friday for part of Singapore ArchiFest. On the topic of saving global heritage, where we're bringing together 10 speakers from all over the world to talk about our global heritage and perhaps using robotics and technology as part of saving some of that. I hope so too, it'll be interesting. Last but not least, the final mention must be connected to Philip's last project in his presentation, the Bamboo House Village, because it is the main image for RIBA China photography competition, 88 places and spaces. Still have time to submit. Closing date is 29th of September. So do that. We really want to celebrate Chinese architecture and some great, and it will be part of the lunar calendar for the top 12 as well. On that note, thank you again, Philip. Very much grateful for your time. Until next time, stay safe and hope to see you very soon. Have a lovely weekend. Bye-bye.
Thanks for the invitation. Bye-bye.
Pleasure. Bye-bye.